Greetings everyone. This is Ayush Nishad, enrollment number 203111006, and this is my presentation for the course creation 310 applied inst applied instrumentation taken by my Professor Mayank Goswami. So we'll start with the presentation. So this presentation is on linear variable differential transducer LVDT, and this LVDT. So we'll jump right into it. So the principal working of LVDT is basically the mutual induction between two different coils. So there is one primary coil, and then there are two secondary coils, and those secondary coils they generate an EMF due to mutual induction. So this is the setup as you can see here. And in this, you can see there is a primary winding, P1, and there are two secondary windings, S1 and S2. There is a soft iron core in the middle. This iron core is what moves. This iron core moves inside and outside. And this iron core, what it does is, as you can see, uh, it captures the electromagnetic field, and this is what changes the flux in my secondary coils. So my primary coil has a signal which is an AC signal, and that AC signal, as you can see here. So this is my primary coil. These two are my secondary coils, A and B. So my primary coil has a primary signal, En, and when my iron core, this is my iron core in the middle, when my iron core moves, it produces a secondary signal E naught in both of these coils. So you can see, as you can see here, AC input. So as it moves, the amount of flux captured inside this moves. The amount of flux is captured inside the core, and when my core is on one side of, as you can see here, when my core moves, when the core is on the left side, on the A position of the coil, towards the A position, EMF is generated towards A. It is biased towards A. There is more voltage being induced here and less voltage being induced here. So the higher voltage in A, ES1, ES2, S1 is my A coil, S2 is my B coil. So more voltage in A uh, causes a higher EMF on the A side, and when my uh, core moves towards B, core moves towards S2, then I get a negative voltage in the reverse direction, as you can see here. This is my demodulated output. This is my modulated output. If I connect my oscilloscope, this is what I'll receive, and uh, uh, with an oscilloscope, I'll receive this, and without an oscilloscope, with my demodulated output, I'll receive this. So now we'll get to the advantages and disadvantages of LVDT. LVDT has a very linear response, and it is very accurate. It only becomes non-linear when it is towards the ends. If my core is right near the edge of the coil B and a lot of magnetic field is escaping outside of these coils, then I'll be having a non-linear response. So this linear response is very desirable, and that is what helps us when we are using. It has virtually infinite resolution. It only depends on how little can we move it, and we are limited by our measurement parameters. If our measurement is infinitely precise, then I can have very precise measurements and very high resolution. And also, since it is a very simple setup, there is only a iron core moving along. The only point of failure is the movement of my iron core, a mechanical point of failure. And that doesn't happen very easily if it is being used under the well-defined parameters, and uh, if it is being taken care of. So it has very high repeatability. Now the output is already high enough so that you don't need an amplifier. It makes a very easy setup, and it can be made very easily. It is very sensitive, as I described earlier. And this sensitivity is dependent on the number of rotations in my coils. And if I can use very thin wires and rotate them many times, then I can have very high sensitivity. Basically, very small displacement can create a lot of voltage difference. Though this limitation on number of coils is also one of the disadvantages, large displacements are required to produce a differential output. But if it is humanly possible to create very thin wires, then we can have very high sensitivity. It is very robust and hardy and can be used in very extreme environments pertaining to its very easy setup. So disadvantages, as I pointed out earlier, it is not very nice. It doesn't behave very nicely because sometimes large displacements are required. The displacements can be in order of millimeters, but millimeter is also sometimes too large depending upon your application. They are sensitive to stray magnetic fields. As it is apparent, if there is a stray magnetic field around here, then it will produce an EMF on the coil B, and that is undesirable. So to get a DC output, if it is desirable to get a DC output, we always need a demodulator, which complicates my setup a little bit. And temperature also affects my setup as it affects the resistivity and sometimes the linearity of induction and all of that. So these are the advantages and disadvantages. Now LVDT Apple has very many applications, and since its main purpose is to show a linear nature with displacement, it finds a lot of uses in power turbines and turbofan jet engines to see the amount of pressure and amount of movement in those blades. Hydraulics, because hydraulics have movement in them. Automation processes and robots, the amount of displacement is an important concern to know uh, where the parts of my robots are to proprioception, for the proprioception of my robot arms. Now, it can be used as very sensitive force measuring device too, because when we are moving our core, I have to apply a force to for the continuous movement of the force, because my continuous movement of my core, because the induced magnetic fields do not want the amount of flux inside them to change. So I have to apply this external force, which is converted into the extra energy, which induces electric, which induces an EMF in there. So it can be used for that, but it can be used as a force, pressure, tension, weight, torque, etc. Mechanical para to measure mechanical parameters, because it is sort of similar to how a strain gauge works. When I am trying to measure some force, if I apply some force on an object, it will compress or extend or show some sort of deformation, and that deformation is a displacement of sort, and that displacement can be measured using an LVDT. So that is it for LVDT. Thank you and have a nice day.